our first electronic demo for PSY 653. We're going to be talking about mediation today.
Yeah, and this is actually a really exciting subject that I think Jem and I both love, is talking about mediation. So let's go ahead and dive right into it. So to start off, we're going to be talking about these paths in mediation, and we're going to be referring to them time and time again. So the first path I'm going to start with is actually our C path. And you can see that on the kind of above the bar. It's the one where it's the independent variable leading straight to the dependent variable. The C path is referring to the path from the independent variable straight to the dependent variable without any mediator present. Now, when we go to our kind of the lower image, we see an A, a B, and a C prime path is what that's called. So the A path will be your independent variable leading to the mediator variable. And your B path is the mediator variable leading to the dependent variable. And then lastly, we have something called the C prime path, which is your independent variable leading to the dependent variable with a mediator present. And so to kind of talk about, and this is referring to Kevin's lecture, where we're talking about how these C, A, and B paths become present and this Barron and Kenny criteria for testing mediation. Now, this Barron and Kenny criteria is a central piece for whether or not it is plausible to test for mediation in a model. So our first step is to show that X is related to Y, and that's equivalent to testing your C path. Then we want to show that X is related to our mediator, which is essentially equivalent to your A path to show that there is a relationship. Next, we're going to show that Y is related to our mediator, which is going through your B path. And then lastly, we want to show that our mediator explains the relationship between X and Y. And all that really is showing that that the mediator explains the relationship between X and Y. So we use a semi-partial correlation to note that that's present or not. And what we'll see is that when we do a semi-partial correlation, controlling for M, we'll see that our correlation goes towards 0. And I want to know, you must meet all of this criteria in order to run a mediation model. So we'll be running through these before we even start testing for mediation.
And just really quickly jumping in there, so all of these criteria are basically showing that the mediation path could plausibly exist. And so we're not even going to test mediation without conceptual justification for it. Basically, there has to be a reason why X might affect Y through the mediator variable. And so all of these are just showing that those paths exist. Cool. So in our demo here, we're going to be loading the following libraries. These should all look familiar for tidyverse psych, and then ppcore, if you recall from last semester when we did semi-partial correlation, and then we're going to do the mediation package, which you might need to install. The data file for this is the mediate2.csv. It'll be up on Canvas. This is just a simulated data set, just for teaching the interactions between the variables. And we're not going to go through the steps of actually visualizing the data, checking descriptives like we normally would, but just know this is best practice when you're doing actual mediation.
And something that we want to kind of look into with our data set that's going to be essential because of the Barron and Kenny kind of criteria for plausibility for testing mediation is we're going to be looking at the correlation between all of our variables. So it's kind of essential that you run a correlation. So you just use the core function on our data set, and we're going to run all the correlations, and we're going to be referring to these over and over again, actually, as we go through the Barron and Kenny criteria for testing for mediation. So we're going to have our first analysis that we're going to run is we're going to try to see, we're going to test the hypothesis that X4 mediates the relationship between X1 and Y1. So remember, this is just simulated data, so we're not working with real kind of variable names, but just focusing on these in general. So let's focus on step 1 of the Barron and Kenny criteria for determining if there's even plausibility run on with mediation. So let's first look at our correlation. So we want to look at the relationship between X and Y, which was X1 and Y1, which is highlighted in red on the slide. Then we get the relationship between our mediator and our predictor variable, which is X4 and X1, and which is highlighted in purple. And then lastly, we get the relationship between our mediator variable and our Y variable, which is the relationship between X4 and Y1, which is highlighted in blue. And as you can see, I've also labeled them as a C path, A path, and B path. So we have to ask ourselves, based on this information, do we have justification to test the mediation hypothesis from the Barron and Kenny criteria? Well, I'll tell you, based on this negligible correlation between the mediator variable and our predictor variable of 0.04, which is a very small correlation, really we're actually saying that we don't have justification to test the mediation hypothesis. So in general, you really will, we would stop here and would not continue with any mediation at all, actually. This is the ending step.
Yeah, so basically what was happening there is that the predictor variable wasn't even related to the mediator. And so if there's not any relationship there, there's no way that mediation could be occurring. In that case, it's more likely that the mediator is a predictor and not a mediator. So that one we can't move forward on. Now let's test the hypothesis that X4 mediates the relationship between X3 and Y1. And so we do the same thing that Neil talked us through in the previous slide. The first step here is we look at our correlation matrix and we look at the correlations between our variables of interest for each path. So in red we have the correlation between our X and Y. That's our C path, 0.5053. Our A path between the predictor and the mediator is 0.3425 in purple. And then in blue, we have what our B path is, which is the mediator to the outcome variable, 0.4105. And so in this case, because all of these correlations are of a moderate size, they're not negligible. You can slide. Yes, we can move forward in mediation. Basically, we have justification. We know that there's plausibility there's a relationship between the predictor, the mediator and the outcome, and then also the predictor and the outcome. All three of them are here. So we can move forward. After we look at those initial correlations just from our basic correlation matrix, the next thing we'll do is we'll take a look at the semi-partial correlation. And so if you remember back from last semester, what we're doing here is we're looking at the relationship between X and Y, partialing out the effect of that third variable. This is important because we want to know, is there any part of the relationship between X and Y that's explained by M, by the mediator? And so here our estimate is 0.399. That's the semi-partial correlation between X and Y with the effects of the mediator removed. And so what we're going to do is compare this to the direct path from the previous slide, the correlation between X and Y, 0.5053. And because this correlation is smaller, we're seeing that partial mediation is plausible. There's part of the relationship between X and Y that involves M. Now, in this case, if the partial correlation was also equal to 0.505, we wouldn't have justification for partial mediation because M wouldn't explain any of that relation.
So next we're going to compare these models using hierarchical regression, which is something that I think we're all familiar with from past classes on hierarchical regression. So nothing has changed here. So the only difference now is we will be regressing the outcome variable, so Y1, on our predictor. That's our baseline model. And then we'll be adding in our mediator variable into the other model, so into regressing on the outcome variable with our main predictor, and then just simply running an ANOVA to compare the two models where we compare the R-squared values. And as you can see from the results here, we can see that M2 explains significantly more variance in the outcome than M1, just judging by the you can see the F value is really high, and we have a lower P value, indicating that this is indeed explaining more variance than our baseline model. So that's next step, or more justification that we can continue on to run a mediation model. So we're going to go ahead and go to step 4, which is testing the mediation model via psych mediate. Now, just a little kind of note, you'll notice that every time we reference the mediate function, we have to put this psych : mediate. That's because we're running into something called package to function conflicts between packages. What's essentially happening is that the psych package and the mediation package both have a function called mediate in it. So R doesn't know which function to pick up. So we have to tell it that we are going to be using the function mediate from the psych package in order to run our mediation model. So the way that the psych mediate function works is it looks a lot like a normal regression model. The only difference is we're going to be indicating what our mediator variable is by putting parentheses around it. So x4 is our mediator variable here. So we simply put parentheses around it to indicate that that is our mediator variable. And we save that into a new object. We're calling that object fitmed. And then we simply run a summary on that our new object. And it'll actually give you an output that looks a lot like this. So there'll be a lot of windows that'll be associated with here. What we've done here is we've labeled what each of these windows correspond to. And actually in the next slide, we'll have a greater detail of what each window is representing within the mediation model. So I'm going to pass it over to Gemma.
So we'll just quickly talk through what all of the windows are. Neil made this awesome schematic of diagramming out the order that they come in. So the first one, this is one of my favorite parts about this package. That gives you this diagram that plugs in the estimates or the slopes for each path. So we have the A path, the B path, and the C prime paths all labeled for those estimates. The next one is the function call. It gives you just a list of what's in each window. Then we have the estimates for all of the paths. And I think it'll be easier on the next slide to look through. Perfect. Yeah, so in window 3, there are a couple different estimates here, but we're going to focus on the values for x3 because that's our main predictor. So that's the C prime effect that we're looking at. We also have the C path, which is essentially the relationship between x and y when the mediator variable isn't considered in the model. And then it goes through, and you can see it labels each of the estimates for each of the paths. And Neil, can you move that up a little bit? The bottom's cut off.
Oh, yeah, okay, I see. Let me try this again. Oh, no. Unfortunately, my computer's not letting me move this up. So we're going to put it down here for now. It's going to be a little smaller screen for now.
Windows 7 is very important because this is what's going to tell us if the mediation effect is significant. And so something that's really important about mediation is that when we're looking at the effect of the indirect path, which is the A path times the B path, we don't just look at our normal p-values and F statistics, or T statistics, I apologize. Essentially, we're going to look at the bootstrapped estimate for the confidence intervals here. That's how we determine significance. Do you want to go to the next?
Yes. I think that should be good.
Yeah. And so Windows 7 here, we're looking at the confidence interval for the estimate. Now you see the estimate under Y1 is 0.05. And if you go back and look at those estimates, that's actually if you multiply the A estimate times the B estimate, you'll get that. And then the bootstrap confidence interval, if it does not contain 0, then you can determine that this mediation effect is significant.
Mm-hmm. Yeah, and we have evidence for some partial mediation because of this. What was on the next slide? Yeah, so that's really what you're looking for, is to see if there's your confidence intervals contain 0 or not, and if they don't contain 0, then we have evidence for partial mediation, just as Gemma said.
Mm-hmm. And one thing that you can also do is you can actually calculate the proportion of the effect that's mediated if you divide the indirect effect by the total effect, which is the C path. And so you can just pull those numbers directly from the slide before. Here we have 0.05 divided by 0.29. 18.6% of this effect is mediated. And so some journals will want to see that, not only is the mediation significant, but how much is being mediated.
Yeah. So next we're going to show you a different way of testing a mediation model. This is through the mediations package function called mediates. So this one runs a little bit differently than the way that the psych package did it before. So it's got a few steps to it. The first step is we're going to regress our mediator variable, which is x4 in this case, on the predictor variable. So we're using our predictor variable to actually predict the mediator variable, which is equivalent to our A path, actually. Then we're going to actually fit the entire model where we have our outcome variable regressed on our main predictor variable and the mediator variable. And we need to store those in their own separate objects. So here we have them stored as fit M for the mediator model and fit Y to indicate the full model. Then, utilizing the mediation packages function called mediate, we first plug in the mediation model separated by a comma, and then we use the full model, and then we use another comma, and then we indicate what is our actual treatment effect here. Here, it's our main predictor variable, which is x3, and then we indicate what the mediator variable, in our indication here, our mediator variable is x4. And then we simply save that to an object. We're saving that into a new object called fitmed, and then we get a summary of that fitmed object that we just created. And this is going to produce some different output, but we kind of show you how it relates to the psych package mediate function as well in the next slide.
Yeah, and so using this function, technically you wouldn't need to use both the mediate function from psych and the mediate function from mediation. But it's useful to do both because they give you the information presented a little bit differently. But they both essentially do the same thing.
Yes. And they're both using the bootstrapping method in order to create these output here. So as you see on the kind of bottom left of the screen, it says simulations 1000. So this actually ran 1,000 simulations of the bootstrap method so that we know that our results are a little bit more accurate. So there's kind of four pieces of information here. You have your ACME, which is the average causal mediated effect. So this is the effect of the mediator variable low, the effect of the mediator alone. So it's equivalent to that Windows 7 in your psych output, which we kind of determined was the kind of most important window. So this is the indirect effect of your mediator. Next, we have the average direct effect highlighted in red, and this is equivalent to your C prime path. Then we have the total effect, which is just going from from your independent variable to your dependent variable, which is equivalent to your C path in window 4 on the psych mediate function. And then lastly, we have the proportion mediated, which is highlighted in orange, which is the proportion of variance explained by the mediator. And if we go back to that calculation where we took our A path times our B path and divided it by the C path, this is essentially the proportion, just percent explained by our mediator. And it really has a lot less information. It has a lot less outputted to you than the psych mediate function does, but it really contains all the necessary information that you need. Mm-hmm. And that really concludes your first kind of run through the mediated model using X3 as the mediator. So we're going to move on here to another analysis where we're going to test the hypothesis that X4 is our mediator. X4 mediates the relationship between X5 now and Y1. Unless, Gemma, you had anything to add to what we had before? Just want to make sure.
I don't think so. We can hit it moving on.
Okay, cool. We're moving on then. I'll let you take this, Gemma.
So once again, new analysis. First step, we want to check out our Barron and Kenny criteria. Do we have justification to test this mediation? And so we look at our correlation matrix and we identify the correlations of interest. So our relationship between X and Y, X and M, that's our A path, and then M and Y, our B path.
So we just simply have to ask ourselves again, do we have justification to test the mediation hypothesis? Mm-hmm. And with a big old slap on there, yes, we do, because we all have moderate correlations that we can go on in order to determine and test our mediated model. So yes, 3 out of 4 of the steps have been tested from the Barron and Kenny criteria for testing mediation.
Mm-hmm. So with those criteria met, the next thing is to test that semi-partial correlation, which again, is there basically a part of the relationship between X and Y that's explained by M? And so we run that, we get an estimate of 0.519. And what we'll do, if we'll compare that to the relationship between X and Y that doesn't take M into account from the previous slide, which was 0.6405. This is smaller by 0.12 in the correlation size. So we do see the indication for partial mediation being plausible. So there's a part of the relationship between X and Y that involves M. One thing just to add here, so we probably don't have justification for full mediation because we know that part of the relationship is explained by, is not explained by M here. If the correlation between X and Y without M was negligible, then we'd have to rethink our variables.
Yeah, precisely. And as Kevin mentioned in lecture, it's very hard to reach full mediation with the models that we are oftentimes looking at in our field.
Yeah.
So what do we do now? We simply compare our models via hierarchical regression again. Now, so plugging in your X5 predicting Y1, and then for the second model, you plug in your mediator variable, and then we use the ANOVA function to compare the two models to see are we explaining significantly more variance by adding in the new predictor variable, which is our mediator variable here. Mm-hmm. And what do we see? Yes, we do. We see model 2 explains significantly more variance in the outcome than model 1. So again, it continues to give us justification to continue on to run a mediation model.
Mm-hmm. And just one thing to add on to this, as Neil said, this gives us justification to test mediation in the sense that it gives us justification to include X4 in the model. Mm-hmm. Hierarchical regression doesn't mean that there couldn't be a moderation effect. It doesn't mean that there couldn't be just 2 independent effects. It could be mediation. It doesn't tell us the nature of the improvement that X4 adds to the model. It just tells us that we're good to go by adding it.
Yes. So we pretty much, again, we're using this mediate function from the psych package. So we use those 2 colons to indicate that it's coming from the psych package. And we use our outcome variable regressed on our predictor variable, which is X5. And then adding in our mediator variable, make sure that it's enclosed in the parentheses. And then indicate your data set, and then just give us a summary of the object we just created, and it will give us our output again. We're not going to go through all the windows again, but we will focus on, I like window 1 a lot because it really just, I like to visually look at my mediation. Mm-hmm. And then window 7 is the next one that we're going to look at. We're not going to really look at all the other ones in between, but they're all very important windows and ones that you should really look at when running a mediation model. Mm-hmm. So here's our window 7. As you can see, we have a bootstrapped analysis of 0.01. However, when we look at our confidence intervals, it goes from 0 to 0.01. And really, because there's a containment of 0 in there, or at least very close to 0, because I assume it's rounding down, we're lacking evidence for any partial mediation from our bootstrap 95% confidence intervals. So something to keep in mind, even though we pass all the Barron and Kenny plausibility, we're finding evidence that really we may not have mediation despite passing all of those plausibility tests.
Mm-hmm. Yeah, so even though we had justification to include both of the predictors in the model, basically we're finding that our mediation hypothesis wasn't supported. And there might be another relationship between these variables that we want to think about at this point.
Mm-hmm.
But first, we just wanted to show you how to do the mediation model for this analysis using the mediation package. And so as Neil walked you through before, you create two different models up at the top. One that doesn't include the mediator and one that does. You run through that code with the mediate function. And then our output, as we walked through before, is all equivalent to the stuff you get from the psych package mediate function, but just presented a little bit differently.
Yep. And as you can see, our lower confidence interval, although it doesn't technically contain zero, it's very close to zero in the average causal mediated effect highlighted there in blue. So really, again, we're coming to the same just kind of reasoning that there really doesn't seem to be much evidence for a mediated effect here. Mm-hmm. That ends the slideshow.
Yeah. So those are a few different examples about looking at mediation analyses and a few different ways that the results can go. We'll have these slides not in video form as well as the activity for today posted, and let us know if you have any questions.
All right. Thank you so much, everybody.
Thanks.